The following content is created by DrAvitech. Your support and donation will help me continue to offer high-quality educational resources for free. To make a donation, send an email to 6drcyril@gmail.com or comment donations below. Welcome guys, I'm DrAvitech. In this video, we're going to be solving this very problem. We're asked to determine the half-range cosine series. So as I've explained earlier, what we do is, if you're asked to find the cosine series, you're basically treating the function as an even function. So the full range, when it's full range, it's an even function. So you're given just half part of it. So since you're given the half part of it, the formulas you'll be using are just the same formulas you used if the function would have been even. So you're only going to be looking for a naught and a sub n. So to start, this is a naught. So this is 1 over pi. Why do I like writing 1 over pi? This would be 2 over pi. Integral from 0 to pi, f of x dx. This is because if you are taking half range, to get the full of it, you need to multiply by 2. So you need to double it. That was what we did during even functions, if you remember. So this will become 2 over pi. Then we have, then we have the integral from 0 to pi. Now f of x is 4x, so this will be 4x dx. So this is 2 over pi. Now this 4x, the 4 is a constant. So when you bring out the 4 to make this very 2, this will make it 8. So this is 8. Then we have the integral from 0 to pi. What will be left is x dx. So this is 8 over pi. Then, if you integrate this x, there's a 1 here. So this will be x squared over 2. And then from 0 to pi. So this will be, beautiful, 8 over pi. Now, anywhere I see x, I'm going to put pi. So this will become pi squared over 2. And then minus 0 squared over 2. So there's a part for the upper limit, there's a part for the lower limit. So this will be 8 over pi. Then this will be pi squared over 2. Now this 0 part is gone. Now 2 here is 1, 2 into this is 4. Pi squared over pi will give me just pi. So this will be 4 pi. That's just what it's going to be, just 4 pi. Next, a sub n. A sub n is 2 over pi, integral from 0 to pi, f of s cos nx dx. So that's what my a sub n will be, because I'm treating the function as an even function. So that's what the formula would be. Remember to watch the necessary videos in the playlist to enable you to understand every single thing. So this will be 2 over pi, integral from 0 to pi. Now f of x is 4x. So this is 4x cos nx dx. Now this will be, the 4 can come outside. So this will become 8 over pi, integral from 0 to pi of s cos nx dx. Now this will be 8 over pi. Now if you look at this, we're going to use integration by parts. So I'm going to write my x. First. Then give some space. Differentiate x, you get 1. So differentiate x, you then get 1. Next, this is cos nx. You're going to be integrating this. So integrate cos nx, you will get sine nx. Then don't forget, you must always divide by the derivative of nx. So this nx, when you differentiate nx, you will get n. So you divide by that n. And this very bracket you see, you are going to also what? Integrate it again for the second side, because there's a number here, 1. So you also need to integrate this. So to integrate this, when you start with the sine, when you integrate sine, you get minus cos. So this is minus cos nx, divided by, when you integrate nx, you will get n. That n will come and miss this very n that has been here. So make it n squared. And then this is plus minus. And the interval is 0 to pi. One thing that makes me laugh so much, or one thing that makes me happy, is whenever I see this cosine, whenever I see this sine, sorry. Whenever I see this sine, I get very happy because within this interval, the value is 0. So sine n pi, when you put pi here, sine n pi is 0. When you put s as 0, yes, sine 0 is still 0. So this guy is just 0. I don't really stress myself. So this will be 8 over pi. Now what will be left is just this part. So minus minus is plus. So this will be cos nx over n squared from 0 to pi. Now the n squared is a constant. So let me just bring it out. So this will be 8 over n squared pi. The what will be left is cos nx from 0 to pi. Okay, it's getting beautiful. All right. Now, anywhere I see x, I'm going to be putting pi. So this will become 8 over n squared pi into cos n pi, that's the upper limit, minus cos 0, lower limit. So this is 8 over n squared pi. Now, what is the value of this? It's a special value, right? Cos n pi is equal minus 1 to the power of n. So this is minus 1 to the power of n. Then cos 0, 2, special value 1. All right. Now, remember that this, if you've been following me, this type of brackets, they have a particular behavior. They behave very funny. So let's get started. When n is even, because we're going to be putting even and odd numbers. So it's going to behave the same way for even numbers and behave the same way for odd numbers. So when it's even, there's a particular way it will behave. Then when it's odd, there's also a particular way it will behave. So if you look at this properly, we have minus 1. The n, since we're picking even, let's say 2, and then minus 1. So this is minus 1. Minus 1 squared is plus 1. Minus 1 squared is plus 1. Now, what is 1 minus 1? That's 0. So this tells us that our a sub n, which is 8 over n squared pi, times this bracket, the bracket is now 0. So it means everything here is 0. So my a sub n is 0 whenever I'm dealing with even numbers. Then next, when n is odd, when n is odd, I'm dealing with just the brackets. I want to see how the brackets will behave. So minus 1 to the power of, let's pick an odd number, 1, and then minus 1. Anything raised to the power of 1 is that same thing. So this is minus 1, which is then minus 2. So there's going to be an answer when it's odd. So let's go back. Our a sub n is 8 over n squared pi times this bracket. Now this bracket is now equal to minus 2. So a sub n will then become 8 times this is minus 16 over n squared pi. So this is what we have as our a sub n. And this is when n is odd. So that's when n is odd. N has to be odd. All right. Now let's proceed. So let's find our Fourier series. So f of x will then become a naught over 2 plus the sum from n equal to 1 to infinity of a sub n cos nx. All right. So this is f of x equal, now a naught is 4 pi. So this is 4 pi over 2. Looking kind of weird. Let's proceed. So this is 4 pi over 2 plus the sum from n equal to 1 to infinity of this. This will then become a sub n is minus 16 over n squared pi cosine of nx. Okay. Now, 2 here is 1. 2 into this is 2. So this will be 2 pi. Now, what is the constant at this part? The minus 16 is a constant. This pi is a constant because your summation is with respect to n. The summation is with respect to n. So anything that does not have n is a constant. So bring out the minus 16 over pi. And then the sum from n equal to 1 to infinity. What will be left is 1 over n squared cos nx. Now remember that this is only happening when n is odd. So you have to always remember. So when n is odd. All right. But it doesn't really make sense to be writing odd here when you can just replace at this place, at this part of the work. If you replace your n with 2n minus 1, you'll basically be getting all odd inputs. But this is the answer. So let's just expand this a little. Let's expand this a little. So this is f of x equal to 2 pi minus 16 over pi. Then we're asked to do what? We're asked to do this. So let's bring out some terms here. When n is 1, this will just be cos x. Plus, when x is 3, this will be 1 over 3 squared, cos 3x. When s is 5, this will be 1 over 5 squared, cos 5x. And then just like that. Now, what did I follow? I followed this expression. So when you put your 3 now, this will be 1 over 3 squared cos 3x. Anyway, you see n, that's where you'll be putting the number. So when it was 1, 1 over 1 is just 1. Anything times 1 is that same thing. That was why I just wrote cos x here. So this will be the answer to the problem. And with this, I am done with solving this very question. So let's move on to the next. I'll see you in the next video.